Hello friends, let's start our today's discussion which is regarding resistors. So, whenever we talk about resistors, the first thing that comes to our mind is the opposition. Now what does this resistors do? It provides opposition for the flow of current in a circuit. So these resistors are actually divided into two parts. The first one is the wire bound resistors. It is made up of large wires which are wounded, or it is in the form of windings to provide us the suitable resistance. But the problem associated with this wire bound resistor is that for preparation of a very large resistance, we need a very large length of the wires. So where the arrangement or the suitable preparation will be very difficult. The wires are actually made up of the wires that has been used over here are made up of alloys like, what are the alloys that is being used? That is your manganese or constantan. So these two materials are used for the preparation of the wire bound resistor. Why these two materials are used? Because these materials are almost independent of temperature. As we all know that resistors are temperature dependent. That means if you will go on increasing the temperature, the resistance is going to vary. So because of the problem associated with this wire bound resistors, because we cannot create or cannot very large resistances cannot be prepared, so we will go for carbon resistors. So what is a carbon resistors? These are actually made up of your carbon black, then your resin binder, and clay. They are mixed together to form the cylindrical shaped rod. So what does the cylindrical shaped rod do? Now the carbon resistors looks like this. If you can see here, these are the carbon resistors. You can see what I am holding in my hand are the carbon resistors. The outer covering of these carbon resistors are actually ceramic, made up of ceramic or plastic. So you can see here there are various colors or rings associated over these carbon resistors. You can see these colors over here. So these colors are actually helpful in reading the resistance of these resistors. So now I will discuss here how to read the resistances of these carbon resistors. Now what is the advantage? First of all, let us discuss what is the advantage of using this carbon resistor over the wire bound resistors. These are compact. As you can see, it's a very small. So these are compact. These are small in size and very cheap. And by using this resistor or this carbon resistor, you can create or you can construct the resistances of few ohms to few million ohms very easily. So let's just understand how to read the carbon resistors, the resistance value of the carbon resistors. So the color coding of carbon resistors. So let's proceed how to. There is an acronym you need to remember. What is that acronym? The acronym is BBROY off. I'm just writing this off in a circle because this is an optional term that is not going to occur in the acronym. So BBROY of Great Britain, I'm just writing the initials. Harder, this is the optional term, just to remember the acronym that is going to help you. A very good wife. Wearing, this is an optional term. Gold, silver necklace. So now what does this acronym is going to do with the color coding? So for BBROY, BBROY, this represents colors, various colors. So you see there are occurrence of 3 B's. B, B, here is another B. So these B's colors you are going to remember very precisely. So first one represent black, the second one represent brown, and the third B that is going to occur in this acronym represents blue. Similarly, you see G occurs twice. So you need to remember this G very precisely. So this is first one represents green, and the second one that is occurring in this series represents grey. And the rest of the colors are for red, O for orange, Y for yellow, here V for violet, and W for white. So now we have to just number it in a starting from 0. That you need to remember. We have to number it starting from 0. So first one is 0, black is 0, brown is 1, red is 2, orange is 3, likewise 4, 5, 6, 7, 8 and 9. And what does this gold silver necklace do with our acronym? This G represents gold, this S represents silver, and this necklace that I am telling, that represents no color. So this gold will going to represent, that is your plus or minus 5% tolerance. Silver is going to represent plus or minus 10% tolerance. And no color is going to represent plus or minus 20% tolerance. So this 3 term represents tolerance. I'm just going to, afterwards I will tell you what does this value 5%, 10% and 20% represents. So now how to read the resistance value. So suppose I have a resistor like this, and it has, in general, a resistor has 4 rings. You can see here, if I will show you, it has in general 4 rings over it. So 4 colored rings. So the 3 rings which are very closely spaced towards one edge, and the 4th one is going to be little apart. That is how you are going to hold it. That means the 4th ring should be towards your right hand side. So now you see that the first ring, let us just name it, that is W, X, Y and Z. The first ring represents the first significant figure. The second ring represents the second significant figure. I am writing significant figure as SF. Then the third one represents the multiplier. And the 4th one represents the tolerance. So this is very interesting. So what should be my resistance having the resistors of these 4 rings? This will be equals to the first significant figure W times the second significant figure, that should be multiplied. Multiplied into 10 to the power the multiplier. My multiplier is y. So this will be equals to Wx into 10 to the power y plus or minus Z% tolerance. So this is how we are going to represent the resistance of the resistor. This is one type of coding system. Then another type of coding systems are also present. That is, sometimes we have resistors having the entire body. This is the entire body of one color. That color is W. The A's of this or the ends of this resistors are of one color. So this is the ends which is of one color. Let us take the ends to be equals to X. Then there will be a dot present over this body, that is of the representation Y, and there will be a ring that represents your tolerance, that is equals to Z. So this is the ring which represents Z. So in the similar manner you will write the resistance of this type of resistor also. That is, first the resistance will be written as first the body color, which is I have chosen it as W. The ends, then the ends will be of same color. That has to be multiplied with the first significant figure, multiplied into 10 to the power the dot value. Dot value I have chosen it as Y plus or minus Z% tolerance. So this is how we are going to represent the resistance of a resistor. Now what I will do, I will just take a resistor and I will calculate the value of the resistance theoretically and experimentally. And by both the terms, I am going to compare whether I am getting the exact value or not. So let us proceed and calculate the resistance of a resistor theoretically first. So let's take the bigger one. Let us take this one. So how, as I have told you, how I am going to hold it? You see, I have to hold that three rings, the three colors are very close to each other. That should be towards my left, and the ring that is just a few distance apart, that should be towards my right. This is the holding procedure. Or you can check that if silver and gold color is there, that should point towards your right hand side. But if there will be no color, how you are going to hold it? That's why I am telling that three bands or three colors will be very close to each other. That should be towards your left. So here if I'll note down the colors, the first one is brown. The first one is brown, so I am writing. The second one is black, you can see here, and the third one is green. So brown, black, green, and the last one is golden. So what is my color coding over this register right now? Let me write. The first one is brown, the second one is black, and the third one is green with golden color. So brown, you can go to the color coding right now. What is the representation of, what is the number associated with brown? That represents 1. What is the number associated with black? That represents 0. What is the number associated with green? That represents 5. And what is the tolerance value for golden? Golden is plus or minus 5% tolerance. Here it is plus or minus 5% tolerance. Means how to write it? The resistance of this resistor is nothing but 10, that is your 10, multiplied into 10 to the power 5 plus or minus 5% tolerance. So what does this 5% tolerance actually indicate? This 5% tolerance value indicates that what is my calculated value theoretically may vary 5% more or 5% less. So now let us calculate it, the resistance of this small resistor, by using a multimeter. So this is my multimeter where we can calculate the resistance experimentally. So as it is coming out as 10 to the power 5, so let me just see what is the work of this multimeter. You can measure various things using this multimeter. So I have to take this knob and switch on it and take it to the resistance option. So this is my resistance. You can see here is ohm. So here it is written 2000K. So that means 2000 into 10 to the power 3. So my range is coming over this value. So that's why I have taken the knob to this position. So let's just keep it over here and calculate the resistance of this resistor. Or if you just note down the display of this multimeter, I'm just keeping it over here to calculate. You see what I am getting. I am getting 988, around 988 or 87. Okay, 988 into 988K, because K will be there, because that is the option I have over there. Okay, it's coming 990 around. Okay, let's take this value as 990. Now you see here I have kept the knob over here. So this is 2000K. So that means I'm getting the experimental value as 990 into 10 to the power 3. Which means this value is nothing but 9.9 into 10 to the power 5 ohm. Yes or no? Okay, that means this much amount of ohm, obviously. That should be remembered. So if it is 9.9 into 10 to the power 5 ohm, my calculated value is 10 into 10 to the power 5 ohm. So what should be my error? So I can calculate whether it is categorically coming under this 5% tolerance range or not. Because okay, let me just calculate the error part by using a calculator. You can see my value is coming, the value is coming 10, but theoretical value, but my experimental value is coming 9.9. So 10 minus 9.9, so it is giving us 0.1. Obviously this much divided by 10 is my actual result, equals to multiplied into 100 is going to give me the error associated with it. So that means the error is 1%, which is coming under. That means percentage error I am calculating. What is the error? So which is coming under the range of 5%. So I hope so this one is clear, that how we are going to calculate the resistance. So let me just show you another one so that it would be clear. So you can see here, this is another resistance resistor I have just hold it. So you can see the colors over here. You can see the first one is orange, the second one is also orange, the third one is brown, and the fourth one is golden. So orange, orange, brown and golden. As you can see, I have holded how I have holded it one. The golden one is towards my right. So the color is orange, orange, brown and golden. So how to represent orange? Orange BB Roy. You can see here the orange one is 3. The number associated with orange is 3. So 3, 3, brown means 1 and golden means plus or minus 5% tolerance. You can see here golden is 5% tolerance. So how to write the resistance? The theoretical value of the resistance is 3 that is has to be multiplied into 10 to the power 1 with plus or minus 5% tolerance. So I can write here this is 330 ohm plus or minus 5% tolerance. So if I will calculate it, so previously the range was very high, so that's why it is in 2000K. The multimeter knob is at 2000K. Right now, since this resistance is 330 ohm, so let us just take it to just take the knob to 2000 place and check whether I am getting that one or not. So I am just keeping it over here, keeping that resistor over here. You can see, just all of you note down the display. What I am getting, you see, it's coming 325, around 325. It's stable at 325. So let's just write it as 325 ohm. This is my which value? This is my experimental value. RE I am writing. So let's just check what is the error associated with it. So just clear it, and it's my original value is 330. Now right now I am getting 325. So that is 330 minus 325 will give you 5. 5 divided by, what is my exact value? It should come as 330. So 330. So this is the percent. We need to calculate percentage of error. So equals multiplied into 100. You see what is the error I am getting? This is 1.51 percentage. So error is 1.51 percentage, which is of course coming under the category of obviously 5% tolerance or 5% error rule. So this is all about my today's discussion. I hope all of you have enjoyed, and you people can remember this acronym, that is BB Roy of Great Britain had a very good wife wearing gold silver necklace, and you can easily calculate the resistance of the resistors. Thank you everyone. Thank you for watching.